So one thing that we're going to deal with in this class is getting angles past 360 degrees in both degrees and in radians. And we're going to have to figure out what quadrant they're in, because we're going to have to use our cast rule and reference angles. So now if you had a calculator and you're asked, where is 4,300 degrees? You could just divide by 360, and this number that you get tells you do 11 full rotations, and then the 0.94, well, does it make sense that this is halfway around, this is a quarter of the way around, this is 3/4 of the way around? 0.94, if we were going in this direction, would have to end in quadrant 4, if you had a calculator. But most often we don't have a calculator, so we have to sort of figure out some strategies for how to find out where something is. Now, does it make sense that if you had 4,300 degrees and you subtracted 360 degrees, which is once around, then that would get you a coterminal angle, an angle that ends in the same place. So if I started with 4,300, I would actually probably, mental math-wise, subtract 360 degrees 10 times to start with, just because the mental math is easy. That makes 3,600. Yes, if you have your tickets, just show me. I'll mark you off. And then everything will be on video afterwards. So 4,300 degrees is coterminal with 700 degrees. And then I could subtract 360 degrees again and get 340 degrees. So 4,300 is coterminal with 340 degrees. That also would tell me it's in quadrant 4, and I wouldn't need a calculator for that. It would take a little bit of effort, but I wouldn't need a calculator. But more often, we're going to be dealing with questions in radians. And so we're going to look at some strategies to figure out radian questions easier without a calculator. Again, if you had a calculator, instead of dividing by 360, you just have to divide by 2 pi, because 2 pi and 360 degrees are the same. And then you would be able to figure out where it is. But what we're going to do as a strategy is we are going to take our number and change it to a mixed fraction. So first of all, do you remember how you would change 23 over 6? Well, for sure I can get 3 full 6s in 23. That would give me 18. There would be 5 left over. So 23 over 6 would be 3 and 5/6, which is negative, would just mean -3 and 5/6. The negative just tells us which direction something is going. Now, then -23 pi over 6, I can just put the pi afterwards like that. Now we're thinking in terms of pi. So if you think of radians, all the way around in radians is 2 pi. That means halfway around is pi. So when I'm trying to figure out where is -3 and 5/6, first of all, the negative, in standard position, I'd start here. The negative means I'm going in this direction. Halfway around means I would have traveled -1. All the way around means I would have traveled -2. Another halfway around, this is -3. This number right here tells us you would have gotten this far. Now we still, I'll change to purple here, we still need to go 5/6 pi more. Would you agree that 5 over 6 is more than half? So if I, from here, went more than half, and ended at my pi over 6 family member, this is going to be in quadrant 1. Now you can use the mixed fraction to very quickly figure out where it is. So for example, well, we'll do some examples together. And the other thing that's really nice with it is because it's in quadrant 1 and because it's a pi over 6 family, you would know that it's coterminal with pi over 6. So, our first assignment that we're going to do, or our first thing I'm going to hand out, we're going to do a couple of them together just so that you're familiar with it. Hand out. After that. And I might have sent a couple extra. Maybe I sent too many. So what I want you to do with every angle that's given, this will be for questions 1 to 8. They give you an angle. And there's 2 assignments at the bottom. So assignment 1 wants you to find out which quadrant it's in, and what is coterminal on your unit circle or on your pi plate. So 13 pi over 6. If I change that to a mixed fraction, is 2 1/6 pi. Very easy for me to see that 0 pi, 2 pi. Very easy for me to see that the 2 means that I'm going to be ending on the right-hand positive x-axis. Does it make sense that any even number will be on the positive x-axis, and any odd number will end in the negative x-axis? The fact that it's positive means once I get to that 2, basically I've gone around this far already. Then the 1/6 tells me I have to go 1/6 pi more. That's half a pi. You see that 1/6 is less than half? You're going to then end here in quadrant 1. So which quadrant is 13 pi over 6 in? It's in quadrant 1. It's coterminal with pi over 6. Because we started with a pi over 6, it's going to be coterminal with a pi over 6. And that's a shortcut for quickly figuring out where it is and what it's coterminal with. Then, let's do another one. Let's try 5. Let's do 5 together. Because it's a bigger number. 101 pi over 4. 100 times 4 is 25, so this will be 25 1/4 pi. So think about my unit circle. It makes sense that the 25 being an odd number, you're going to be ending there. And it's basically going around in this direction. I'm not going to draw all 25 of them. Thank you. Add some dots in there so you can imagine there's 25 of them. You would end there. Then the 1/4 is less than half, so you would stop in quadrant 3. Coterminal with, well, what is your pi over 4 in quadrant 3? 5 pi over 4. Thank you. And when you get to questions like number 9, again, we'll start with just negative pi over 4. Negative means it's going in this direction. It can't even change it to a mixed fraction. It would just end here in quadrant 4. What is it coterminal with? It's coterminal with, what's your pi over 4 in quadrant 4? 7 pi over 4. And then this question has a sign in front of it, yes? Yes. So you would think about your unit circle, and you would say, in quadrant 4, I have these coordinates. Root 2 over 2, comma, negative root 2 over 2 for 7 pi over 4. Which coordinate is signed? The x coordinate or the y coordinate? The y coordinate. So then I could say that this is equal to negative root 2 over 2. That's this assignment. So this weekend, you have to practice lots in this unit to get used to it. Take some time to find out what each angle is coterminal with. And then from 9 on, actually think of your unit circle and the coordinate and which one they're asking for. All right, continuing on in those notes, what you're going to be doing is you're going to be figuring out a bunch of values now without your calculator. So I'm going to pull out a unit circle. I'm going to pull out one of the pi plates and just sort of go through some of the mental math that you're going to be doing. When you see 7 pi over 6, you'd be like, hey, that's one of the ones I labeled. Which quadrant is it in? 1, 2, 3, or 4? It's quadrant 3. So one of the things in my head, I would think quadrant 3. I often only remember things in quadrant 1. Because once you know quadrant 1, you know everything else. So in quadrant 1, I know that sine of my pi over 6 family is always a half. So sine of 7 pi over 6 is also going to be a half, but the next thing I have to think about is my cast rule. If it's in quadrant 3, should sine be positive or negative? Negative. So then sine of 7 pi over 6 will be negative a half. So I don't memorize 7 pi over 6 on its own. I just use quadrant 1, so I have less things to memorize. I think about what quadrant it's in, think about my cast rule, and then I can figure out my value quickly. Tan of 2 pi over 3. So I know that's part of my pi over 3 family. So off in my head I would say, I know that tan of pi over 3 is root 3. One of the things helps me memorize tan of pi over 3 is root 3 is that 3 and 3 match up. And I use this pi over 6 because 3 plus 3 equals 6. That helps me remember tan of pi over 6. Little tricks that I've used to help me remember. Okay? So I know tan of pi over 3 is root 3. So I know that this is also going to be root 3. But I have to decide, it's in quadrant 2. If I draw my cast rule, should tangent be positive or negative in quadrant 2? Negative. So then I would know this is equal to negative root 3. So you see, there's a lot of connected things that you have to use for your mental math. You have to be able to quickly determine what quadrant it's in so that you can use your cast rule to find out if it's positive or negative. You have to have your pi plate memorized so that you know quadrant 1 at least. So when you see, oh, pi over 3 family, you know that it's going to be root 3. This takes practice. The more you do, so when you start, you'll probably have your piece of paper beside you because you'll be checking. Try to do it first in your head, and if you don't remember it, use your paper to check. But try to get it memorized as quick as possible. Okay, so I know it's my pi over 4 family. 7 pi over 4 is in quadrant 4. I know that cos of my pi over 4 family is always root 2 over 2. In quadrant 4, will this be positive or negative? So I think of my CAS rule. In quadrant 4, cos is positive, so this will also be positive, root 2 over 2. You don't have to write that positive sign there. I just put it to show that I thought about it. I reminded myself, oh, you did think about that. You didn't just write root 2 over 2 without thinking. Now we have secant of negative pi over 4. So you're going to get questions with secant, cosecant, and cotangent as well. And those are your reciprocal functions. So you have to remember the definition that secant is related to cos. So I'm going to figure out what cos of negative pi over 4 is, and whatever answer I get, I know I can flip and get the answer for secant of negative pi over 4, because they're reciprocals. So you can just take the answer and flip. Notice, we never flip the angle. The angle stays the same. So figuring out cos of negative pi over 4, well, I know that cos of pi over 4 is root 2 over 2, and since this is in quadrant 4, it would stay positive. Once I figure out cos, I will know that secant is just the reciprocal. Now, do you remember that root 2 over 2 could have also been 1 over root 2? And if you did the reciprocal of 1 over root 2, you would have just gotten root 2. So you'd be fine with either of those answers. In grade 12, you're allowed to have a square root on the bottom of a fraction. They won't deduct any non-simplification marks for that, which is kind of nice. They assume you know how to do it, so then they say we won't take off marks if you leave. Cotangent, negative 11 pi over 6. So off to the side, I'm going to figure out tangent of a negative 11 pi over 6. Now, 11 pi over 6, this is something I do with negative angles. 11 pi over 6 is on your pi plate. It's like all the way in quadrant 4, right? If it's in quadrant 4 in the positive direction this way, if you have a negative 11 pi over 6 and you think about 4 quadrants in the negative direction, does it make sense it would end in quadrant 1? Because if 11 pi over 6 is in quadrant 4 in the positive direction, then negative 11 pi over 6 would be in quadrant 1 in the negative direction. So I know that this is in quadrant 1. I already showed you my shortcut for the pi over 6 family. It's going to be 3 plus 3, root 3 over 3. That's 3 plus 3 is 6. And because it's in quadrant 1, it will be positive. So then cotangent will be the reciprocal. And I write them in both ways right now, just because if you got this question on multiple choice and you got root 3 over 3, but the multiple choice just had root 3, you would need to know how to switch back and forth between. And if you have an axis family, so here's cosecant, so I would need the reciprocal of cosecant this side. Negative pi over 2 on my unit circle, that's right there. Sine is which coordinate? X or the Y? Remember? The y. So I would know this is equal to -1. Therefore, cosecant would be 1 over -1, which of course is still, in this case, still -1. So we did, all of these ones were individual types of questions. The most typical way this shows up on your exam, or on your quizzes, or on your test, one on your test, looks like this, and they're always worth, like, this one has 3 things, so it's going to be worth 3 marks. And it's basically the same questions we did in A through F. It's basically the same question we did from A to F, but it's 3 of them all combined, and then some math to do afterwards. So what I would suggest for these is, in your work stays simple under the question. I'm going to figure out what secant of 11 pi over 3 is. I'm going to put brackets there. I'm going to put a number in there. I'm going to switch colors here. I'm going to figure out cos of -5 pi over 4. I'm going to do that in green. I'm going to put a number in the green brackets. And then I'm going to figure out tangent of 23 pi over 6. I'm going to put a number in there for each of these. I'm going to draw a big line here, and I'm going to do my work off to the side. I'll start by figuring out the blue one. If I want to find secant of 11 pi over 3, I need to find cos of 11 pi over 3. 11 pi over 3 happens to be 3 2/3 pi as a mixed fraction. That's in quadrant 4. Quadrant 4 is important. It's going to tell me this is positive. And I know that my cos of pi over 3 family is 1/2. So this will be positive 1/2. Now that I have that, can you see that over here for secant of 11 pi over 3, we can write 2 over 1. On the exam, they're going to give you 1 mark for that fraction. Half a mark if the numbers are right, and half a mark if you have the right sign in front, positive or negative. Pretty generous. Okay? Next, I'm going to go to green. Cos of -5 pi over 4. Well, 5 pi over 4 is on my pi plate in quadrant 3. Does it make sense then that -5 pi over 4 will be in quadrant 2? Because if you went 3 quadrants in the negative direction, that would be like 2 quadrants in the positive direction. Does that make sense? I go 1. So, first of all, I see 5 pi over 4. I look on my pi plate and I recognize 5 pi over 4 is an angle in quadrant 3. But I'm doing -5 pi over 4, so I have to go in the negative direction. If I go 3 quadrants in the negative direction, it's going to end in quadrant 2. That's important because the CAST rule tells me cos is negative in quadrant 2. Then I just think about pi over 4. What is cos of pi over 4? It's root 2 over 2, so this one will be negative root 2 over 2. And now I can write that in negative root 2 over 2. And finally, purple. Tan of 23 pi over 6. Well, 23 pi over 6 is 3 5/6 pi as a mixed fraction. So I know that it's going to end in quadrant 4. Quadrant 4 for tangent is negative. Maybe I write it here too. It's negative. And I know my pi over 6 family for tangent is root 3 over 3. So this becomes negative root 3 over 3. So again, you would get 1 mark for the blue, 1 mark for the green, and 1 mark for the purple. But you still have to simplify it, and you get no marks for simplifying it, but you have the possibility of losing marks if you make mistakes. So if you make an arithmetic simple mistake, they'll take off a half a mark from here. If you decide to quit writing for fear of making a mistake, they will still give you 3 out of 3, but then they'll give you an E1 error. The E1 error says you just forgot to write down the final answer. And they'll take off a half a mark off your exam for not writing down the final answer. So we still have to simplify this. I probably would cancel out these 2's. Negative times negative is going to be positive. Root 2 times root 3 is root 6. And you'll get root 6 over 3 in the end. I have another handout that has tons of practice. Again, I'll probably hand out too many down some rows. Now on this unit circle practice sheet, part 1 and part 2 are relatively straightforward. Part 3, if you're only going to do part of this, I would say do part 3 and part 4, because they're more exam-like questions like this, okay? And these are a pet peeve of mine, because you just have to write down 3 things to get 3 marks. If you know your unit circle, which you're going to study and know really well, it should be easy. But it bothers me because lots of students just leave it blank and I have to give 0 out of 3 on the exam. So these come up over and over again. They're very predictable and they're very common. So do some practice to get good at it. They're just individual, like they're 3 little individual questions. The blue, the green, and the purple. All can be solved separately. Put the answers down, and then you have to simplify in the end. And because we now have our unit circle and can do things without a calculator because the big idea is that the x-coordinate is cos and the y-coordinate is sine, we now solve trig equations like you did in grade 11, but without our calculator. So in grade 11, this would have been a calculator question, and it would have been in degrees. Now we go to grade 12, and they take the calculator away, and it's in radians. So how do we use our unit circle, our pi plate, to help us solve this? Okay. Theta is the angle. So on your pi plate, you have tons of angles. Pi over 6, pi over 3. You have them in radians, and you have them in degrees. So if we're solving for theta, we're wanting to find an angle. They give us a hint. They say sine of theta is negative root 3 over 2. So from that, you would say, I know on my unit circle, sine is the y-coordinate. Do I ever have a y-coordinate of root 3 over 2? Just start in quadrant 1. Is the y-coordinate ever root 3 over 2 in quadrant 1? Yes. It happens at pi over 3. If it happens at pi over 3 in quadrant 1, you have just figured out, oh, I don't want to use red. So I'll use black. You have just figured out your reference angle. Your reference angle is pi over 3. If you had this in degrees, here's just a reminder. I'll change my calculator into degrees, remind you of what would have happened in grade 11. In grade 11, you would have found your reference angle by doing, sure I can see the question, sine, right? Some important things that don't change because we're doing grade 12. You still need to know all of your grade 11 stuff. But you would have found your reference angle by doing sine inverse. And with reference angles, remember from grade 11, we always find a reference angle by putting in the positive ratio. So even though it's negative root 3 over 2, I'm going to write positive square root of 3 over 2. And by doing this, it will tell me my reference angle is 60 degrees. This is how we would have done it in grade 11. Then once you have your reference angle in grade 11, you would have said, well, wait a minute, according to my cast rule, in this example, sine is negative. So it's either going to be in quadrant 3 or quadrant 4. And in grade 11, you would have taken that 60-degree reference angle and done 180 plus 60 degrees to get 240 degrees. And you would have done 360 degrees minus 60 degrees to get 300 degrees. And you would be done. Now that we're without a calculator and just using our pi plate, we're like, ooh, my reference angle is pi over 3. My pi over 3 family I have completely labeled on my pi plate. What is the pi over 3 family in quadrant 3? That's 4 pi over 3. What is my pi over 3 family in quadrant 4? 5 pi over 3. And we're done. Without a calculator, we have our answer very quick. But that only happens if this is a number that appears as a coordinate on your pi plate. If it doesn't, we're going to still have to do math the way we did in grade 11. With our calculators, finding a reference angle, doing the cast rule, if it's radians instead of 180 plus your reference angle, you now have pi plus your reference angle. But we'll practice those ones as well. So then sometimes these actually happen quite quickly. We want to find an angle. Cos is your x coordinate. Is your x coordinate ever -1? Yeah, that's right here. Done. All you'd have to write for a question like this. Solve it really quickly. The theta would be pi, because the only place our x coordinate is -1 is at this point right here, and that angle in standard position is pi. Tan of theta. Okay, I go to quadrant 1. Do I ever have 1 for tan of theta? Yes. That's pi over 4. Think about my cast rule. Tan has to be negative. I need an answer in quadrants 2 and quadrants 4. So what is my pi over 4 in quadrant 2? 3 pi over 4. As I see hints to help you memorize your pi plate, I'm going to tell you. Have you noticed that every radian in quadrant 2 is always, the denominator is 1 more than the numerator? 4 minus 1 is 3. Pi over 3 would be 2 pi over 3. The pi over 6 one is 5 pi over 6. Always just 1 less. And the one in quadrant 4 is always 1 less than double the bottom. That happens, right? Pi over 6 is 11 pi over 6. Pi over 3 is 5 pi over 2. So those can be little tricks that can help you with your memorization and also help you write down the answers quickly and easily. If you get sine, secant, cosecant, or cotangent, the first thing you'll do is you'll say secant is related to which one? Sine, cosine, or tangent? Cos. So I'm going to write, if secant of theta is 2, then cosecant of theta is 1/2. What family gives us 1/2? Write it off the side. Our reference angle will be x coordinate is 1/2 at pi over 3. And then according to our cast rule, we're looking for where things are positive. So it's going to be pi over 3 and 5 pi over 3. So if you get one of the reciprocal ones, change it with the definition to the other one. All we do is we take the ratio. Notice, this is going to be hard for you sometimes. I'm going to throw out a question. I'm going to tempt you to change the angle. Guarantee I'm going to do it. The angle never changes, but the ratio flips. So if secant of theta is 2, we still have the theta. Cos of theta will be 1/2. And sometimes you have to do a little bit of math to get the ratio by itself. So I had to move the 1 over and divide by 2. Are you okay that I did both of those steps at once? You're going to be doing a lot of quick mental math in grade 12 all at once. So now I would be like, hey, do I ever have a half? That's pi over 6. And I can actually tell you that if you choose, because you know how there's a half with sine and cosine, and there's a root 3 over 2 with sine and cosine, which can be confusing because there's so many of them. Instead of memorizing all 4 and then mixing them up, I find if you choose one of them and memorize it really well, the other ones will fall into place. So for me personally, this is my favorite one to memorize. I memorized that sine of pi over 6 is 1/2. If I have that one strong, I'm like, oh, so what's cos of pi over 6? Well, it's not the half. It has to be the root 3 over 2. And then if I memorized sine of pi over 6 is 1/2, well then sine of pi over 3 can't be 1/2. It has to be root 3 over 2. Which means cos of pi over 3 has to be the half. And all of a sudden, by memorizing one really well, the other ones just fall into place. So instead of memorizing 4 of them mediocre and mixing them up, I memorize one really well. And my favorite one is sine of pi over 6. And we'll talk more strategies on Monday for your quiz on Tuesday. Then according to our cast rule, it's negative. So I need to list my pi over 6 in quadrant 3. Quadrant 3, one more than the denominator. And quadrant 4, one less than double the denominator. Lots of thinking in these questions. Because you've got to really know your reference angles, your cast rule, and your values very, very well. Okay. Turn to the last page. If we get finished this page, then I'll give you time to work on questions for the rest of class. You have to remember how you solve quadratic equations in grade 11. And now we're going to apply it to trigonometry equations in grade 12. So if you had cos squared minus cos theta, this is like, I don't have to write this down, but just imagine if you had this in grade 11 and you were asked to solve for x, what would you do? All right? So we have to think about all of our skills when solving for quadratic equations. You have a quadratic formula, but you're not always going to use the quadratic formula. If you can factor, that's usually faster than the quadratic formula. Can you see in this situation that you have a common factor? You would factor out the x, leaving you with x times x minus 1. And just to review, because factoring is so beautiful and sometimes we forget why we do this. It really is amazing. Why does this help us solve things so easily? Well, it changes something that originally was subtraction. It changes something from subtraction to multiplication. And this is very powerful if something's equal to 0, and only if something's equal to 0. And here's the quick example. I can put two numbers in my head. Okay, I'm not going to tell you what they are. Okay, I got them. You just have to tell me what one of them is and you win. I'm going to tell you that I subtracted those two numbers and I got 0. Can you tell me what one of the numbers is? Anybody want to win? Big prize.
0.
It's not 0. Okay, another guess? No? Oh, no. Any other guesses? 7? You're going to be mad at me. I had 5.32 minus 5.32 and I got 0. How long would that take you to guess? But you've been guessing a long time and probably given up, right? But now, when we factor, we change that subtraction to two things that are now, this is the power of factoring, multiplied. Okay? And I'm going to give you another puzzle to see if you can figure out. I'm going to pick two numbers in my head. Okay, I've got them. And I'm going to tell you I took those two numbers and I multiplied them together and I got 0. Can you tell me what one of the numbers is? One of the numbers has to be 0. The other one was 7.13. You probably wouldn't have got that one. I think I would have just left. Right? If I did this, two numbers in my head, they multiply to get 0. Okay. Every year I teach this class, everybody figures it out, right? They figure it out, say, what's one of the numbers? Everybody says 0. I would have just gone home crying if someone just went 7.13. Crazy. But it has to be 0. So what it means when we factor is we could say, well, if one of them has to be 0, it's either this one or this one. If this one is 0, well, x would have to be 1, because that would make that one 0. And if this one is 0, well, then x would have to be 0. And now solving becomes easy. This is the power of factoring, and why factoring only helps you solve if one side is equal to 0. Now we have trigonometry, so we do the same thing. I'm like, ooh, I have something in common. I can factor out a cos, leaving me with a cos minus 1 equals 0. And because it's so important that it only works when it's equal to 0, it is so important that you write the equal 0. This is the number 1 E error taken off in grade 12. People get so excited about solving, they decide not to write equal 0, and they take off a half a mark. But now that I factored it, now I can split it up here. I said, here's my multiplication. Big green dot is right there. That's where I can split it up. And so either, if it's equal to 0, either this one equals 0, or this one, for this whole thing to equal 0, cos of theta would have to be 1. And now it's a pi plate question. When is your x coordinate 0 on your pi plate? Easy, careful. At pi over 2 and 3 pi over 2. When is your x coordinate 1? At 0? And also at 2 pi, because notice you're going to have to double check your domain often in these questions, that 0 and 2 pi both have an equal sign there. Sometimes the textbook likes, they like to be a little bit mean. They'll do something like this. Notice how there's no equal sign under that 2 pi? So now, in my example, if you forget the 2 pi, you lose half a mark. But in that example with the equal sign there, if you included 2 pi, you would lose half a mark. So we really have to be careful. One of the things I say as a strategy is double check your domain after you're done. So now we have to think about our factoring and solving strategies. If I had this, okay, in your brain, don't write this down, but in your brain, think about if you had this with just an x, what would you do to solve? Would you get the x squared by itself and then square root both sides? Does that seem reasonable? Doesn't, I mean, I can factor that, but it doesn't really factor nicely. I would probably get my x squared by itself, square root both sides. Don't forget the plus or minus or lose possibly a full mark in this question. And then go from there. That would be solving. So I do the same thing with trig. I'm going to get the sine squared by itself. I'm going to square root both sides, remembering to have plus or minus. Now when you square root a fraction, that's like square rooting the top and square rooting the bottom. Oh my goodness. Square root of 4 is 2. And all of a sudden, we get a value that is on our unit circle. And because of the plus or minus, according to our CAST rule, it's going to be in all 4 quadrants. So if I can figure out the reference angle, then I just have to say all 4 quadrants work. Root 3 over 2, well, it's not pi over 6 because I memorized sine of pi over 6 is a half. So I know it's pi over 3. Again, memorizing one can help you figure out other ones quickly. And then every pi over 3 family member for your final answer. Reviewing factoring. Okay, so most often in grade 12, the factoring ones are relatively straightforward. And by relatively straightforward, I mean that the numbers are such that you should be able to figure them out directly. And directly is based on if you know how things multiply out, then when working backwards, you should be able to recognize how they come together. So, when you multiply things out, you would multiply these ones. You would multiply, I'm going to color code things. You would multiply these ones. You'd also multiply these ones, and you would multiply these ones, right? If you had to distribute, and you had a binomial times a binomial, and you had to multiply it out, that's what you would do. Now, when working backwards, you're going to find out that the blue one, the blue arrow, which in English sometimes we use the word FOIL, because we say multiply your first ones, multiply your outside ones, multiply your inside ones, and then multiply your last ones. So it's an acronym we use in English to help us, like, remind us which ones we need to do. But it's something really cool that happens, that your first ones always give you this, your last ones always give you this. And your outside and your inside combine for the middle ones. So this makes our life actually pretty easy, because if I have a 2x squared, and my first ones have to do that, there's really only one option. Can you see that the only option is 2x and x to get a 2x squared? And then I look at my last one. My last one is a 1. If I'm only going to use whole numbers, can you see that the only option is 1 and 1? There's no other possibility. I've now almost completely factored this without even having to think at all. Now my outside and my inside have to give me a minus 3x. So this is going to affect positive signs and negative signs in between. My outside right now is 2x. My inside right now is 1x. I would need a negative 2x and a negative 1x to make negative 3x. And once I'm done, I quickly multiply it out again. Does my last one still work? Negative times negative? Yes, it's still positive. So now we do the same thing, but instead of x's, we would have 2 sine theta and sine theta. That will for sure give me my first ones. And my last ones have to be a 1, so I would know that it's 1 and 1. My outside and inside, 2 sine and 1 side have to give me the minus 3, so they both have to be negative. And then we can split things up here. And we get sine theta is a half, because that's what would make it equal to 0. And here we would get sine theta equal to 1, because that's what would make that equal to 0. Is that on our pie plate? Yes. What family? Pi over 6, because that's one I have memorized. What quadrants? It's positive, so quadrant 1 and quadrant 2. Sine theta is my y coordinate. And what I have that as an axis family. That happens at pi over 2. Sorry that we're going so fast. This is the pace that we need to go in order to be able to finish by the end of the semester. Even right now, I think we're going, I would say we're probably going a little bit too slow. We need to pick up the pace just a bit. You haven't seen this word yet. This is going to be like a key word in our whole next unit. The word identity means something in trigonometry that's always true. And sine squared theta plus cos squared theta equals 1 is one of our big ideas. So one of the big ideas that you learned is that is always equal to 1. The problem with D is currently we cannot solve this question because we have 2 different trig functions in it. It's like having a question with an x and a y. You can't solve it because you have 2 different variables. What did you do in grade 10 and grade 11 when you had an equation with 2 different variables? You got a second equation with those same 2 different variables, and then either used substitution or elimination to solve. What happens in grade 12 is they don't give you the hint. They just assume you know the second equation. And the first equation you would go, hey, wait a minute, I can do a substitution because I can rearrange what's in this blue box, and I can rearrange it as I can either rearrange it to get the cos squared theta by itself, or I can rearrange it to get the sine squared theta by itself. By just moving something over to the other side. But that's going to let me go, hey, wait a minute, I have a cos squared here. I can rewrite that as a 1 minus sine squared. And if I rewrite what I started with, I have minus 3 sine theta. Minus, and anytime you substitute something in, put it in brackets, I can replace the cos squared with 1 minus sine squared. Now this negative sign up front beautifully distributes, which will give me a positive sine squared. I'm going to write that first. I still have this subtract 3 sine theta. And minus 1 and a minus 3 would give me minus 4, still equal to 0. It's a quadratic equation. I have my first term. I have my last term. I have my outside and inside combined. Can I factor this? Well, again, the grade 12 factoring is not going to be too hard. If you have a sine squared, theta, does it make sense that the only possibility is sine theta and sine theta? The only way that the first ones would give me a sine squared theta. Now the last one is a 4. It has some options. Can you see that you could get 4 with 1 and 4 or 2 and 2? So you're going to have to do a little bit of mental math with your outside and inside to figure it out. I hope you can see right away that 2 and 2 is going to be bad. Because if I do 2 and 2, my outside is 2, my inside is 2. And with an outside of 2 and inside of 2, I never get 3. Adding or subtracting 2 plus 2 is never 3. Unless I guess makes mistakes. So I'm going to go with 4 and 1. And the last thing I'm going to figure out what are the signs going to be. I need a negative 3. So my inside is 4. I'm going to make my negative 4 and outside plus 1. That'll give me negative 3. Quickly check, does my last one still match up? It does. And so we get either sine of theta equals 4 or sine of theta equals negative 1. So you look at your pie plate and you're like, okay, negative 1 is on there. My y-coordinate's negative 1 right down here, so I can say theta is equal to 3 pi over 2, no problem. But 4 isn't on my unit circle, so I think, oh, it must be a calculator question, but unfortunately, this is on the non-calculator part of your test, and 4 is not on there. Any idea how we could do this without our calculator? The answer? It's actually not possible. Think about what sine means. Way back in grade 10, pre-calculus. Opposite over hypotenuse. Draw me a triangle. Draw me a triangle. A right angle triangle. Alright, we're going to put theta right here. I'm going to make my opposite side 4 and I'm going to make my hypotenuse 1. No problems, right? I just drew it. What's wrong with my picture? It might be off, a little bit off scale. A hypotenuse always has to be the longest side. So we're definitely have an issue here with my picture. If I try to draw it, it's impossible. So that's why we can do this without a calculator anytime, and this works with sine and cosine, because they both involve opposite over hypotenuse and adjacent over hypotenuse. If the number is bigger than 1 for sine of theta or cos of theta, you can right away, without a calculator, just go, not possible. You can't leave it blank. If you leave it blank, the exam marker can't tell, did you know that it was not possible, or did you blank? And that's why you left it blank. Did you forget? So you do have to say that it's not possible. Sometimes you write not possible, put an X through it, something like that, showing that you know for sure that you can't solve that. So this one only has one answer. We're going to leave E for Monday.